I am Achintya Pandey and assistant professor in IT department at Akgec Engineering College. Okay, so today I am going to explore the concept of virtual function, which is the key to runtime polymorphism. Okay, so in my last video I have discussed the concept of inheritance and all related to the implementation basically in C++. So polymorphism is an very important property of object-oriented programming system. Okay, so in today's videos we will explore the concept of polymorphism, especially static and runtime polymorphism, and the virtual function which is used to achieve runtime polymorphism. Okay, so we'll explore virtual function and their role in runtime polymorphism using C++. Okay, so there are two types of first, what is polymorphism? So polymorphism is basically one thing has several different meaning. The same thing has different meaning, right? One thing has different meaning depending on the concept. Okay, so the concept of polymorphism is basically implemented through function overloading or operator overloading as well as by the virtual function. So this particular polymorphism is of two types. If we categorize the polymorphism, one is compile time polymorphism and second one is runtime polymorphism. Okay, so compile time polymorphism uses the concept of compile time polymorphism can be achieved by either function overloading or operator overloading. Function overloading means one function has one function performing so many kind of tasks, right? So many kind of could have a function whose name is same. All the signature of the function are same, but having different codes. Okay, so we will see here. Okay, and runtime polymorphism it is basically achieved by the virtual function, and this is also called as dynamic or here this is a mistake. This is not early binding. This is the late binding. Okay, so runtime polymorphism is achieved by the dynamic binding or late binding. It is also called late binding. Okay, address and data instruction will have the address at the moment of runtime, right? So now, so in this video we will see particularly the virtual function, means runtime polymorphism we are going to explore. Okay, so in C++ allows base class pointer to point derived class objects. Okay, so let's see with the example. Okay, because base class pointer have the capability to hold the address of base class as well as derived class. It is not the derived class which could hold the address of base class object and all. Okay, so here suppose we have a base pointer P1, base class pointer P1 and base class pointer P2. Okay, derived class, this one is basically this showing the derived class object. Okay, so P1 which is the base class pointer. So in P1 even the object of derived class, the address of object of derived class could have, but not the vice versa. Okay, so let's see how this thing happens. So using a base class pointer that is pointing to a derived class object, we can access only those members of the derived object that were inherited from the base, right? Although it is different from the behavior that Java shows. Okay, so this is because the base pointer has knowledge only of the base class. So although it points to the derived class object, it can point to the base class pointer has the capability to point even the derived class object, but they could access only the members which is derived from the base class only, because it knows nothing about the members are added by the derived class. Okay. So let's see the program. Suppose we have a base class, okay, and there is a function show function, okay. In the show function, simply we are have just single line which is printing base, right? So another function, another class, one is base class, here base. Next is a derived class whose name is derived, and it is inheriting the base class, right, by using the colon. So this derived class has the same function, so, and so has the code derived. Okay. So we have a base class and we have a derived class, right? Now in main we are creating B1 is what? B1 is the base class object. So if we B1, if we write this code B1 dot show, means what we are going to, this show function of the base class will be invoked. Okay. So what is the code in base? Show function, it will print simply base. So the output of this show function will be the base. Similarly, we have a derived class object D1, and D1 dot show, if we will invoke the function in derived class, it will simply invoke this function, and this will print derived. So the output comes as a derived. Now we are going to create a base class pointer whose name is PB. Okay. So base class pointer would have the address of base class. In addition to that, the base class pointer has the capability to have the address of derived class and subsequent all child class derived from the base class. So this one is perfectly valid. Okay. PB equal to address of D1. D1 is what? Derived class objects. Okay. So let's see this one code. So D1 dot show will print simply derived. Now we are going to create a base class pointer which is PB, and PB has address of B1. Okay. So when you will print, access this show function, so this will show, this particular line will simply invoke the show function in the base class, and the output comes as a base. Now in base class pointer, we are also going to point the derived class objects by assigning this particular line. So this PB means base class pointer has the address of derived class object D1. D1 is what? Derived class object. Okay. So now if you will print PB show, PB dot show, since it is a pointer, so we are going to have this particular array, not dot operator. Okay. So this will print base. It will not print, it will not invoke the show function in a derived, although it has the address of derived class object. But when you are going to print, it will not override. Okay. So if you want to print, if you want to invoke the function in the derived class, we would have to do certain things. So we have not achieved the runtime polymorphism. Okay. So how this could be achieved? So this simply could be achieved by using the concept of virtual function. Okay. So all the function calls are statically bound, right? Statically bound, early bound. At the compile time, it will bound. It will simply match, and this will print the, this will invoke the function which is inside the base class, right? Okay. Because although it is pointing to the object of derived class, but the function which is in derived class exclusively will not be invoked. It is just going to invoke the function which is derived from the base class. Now, how the function which is in the derived class could be invoked, that we will see. So now pointer to derived class. Similarly, it is permissible for a base class pointer to point a derived object. The reverse is not true. Means suppose we have a derived class pointer and we are going to point the its parent class base class. So that is not possible. Compiler will give simply error. We can perform a downcast with the help of typecasting, but should use it with a caution. Okay. Okay. So Again, we are going to explore. Here we have a base class. Now we have a derived class. This derived class is particularly inheriting this base class by writing this code. Okay, and we have a third class that is XYZ, and this is simple. Simpler class, right? So we have three class. One is base, another is derived, which is inheriting the base class, and there is a different XYZ class. Okay. So then if we write, see here, B underscore obj is what? Base class object. This is the base class pointer. Similarly, this one is the base derived class object, and this PB means base class pointer is going to point the derived class object. This is okay, but if you write like this, this compiler will give error. Once you downcast, simply typecast, then it is okay, particularly. Okay, so this is something which one should have consideration. Okay, now pointers to derived class. So in fact, using typecasting, we can use pointer of any class to point to an object of any other class, right? So the compiler will not complain, but during the runtime, the address assignment will also, during the runtime, the address assignment will also succeed. But if you use the pointer to access any member, then it may cause runtime error. Okay? Although Java prevents such problem by throwing class exception in case of invalid casting. So now pointer to derived class. So pointer arithmetic is relative to the data type the pointer is declared as pointer. Pointer arithmetic means you are going to perform some arithmetic operation like addition, deletion. So if you are performing pointer arithmetic, means pointer is what? Pointer is going to hold the address. If you perform, say, if you just go 1 in a pointer, so depending on what type of pointer, that much location, that much byte will be shifted. Like if it is integer, so it will be, if you are going to add 1, means it will add either by 2 or 4 bit. Okay, forward. So if we point a base pointer to a derived object and then increment the pointer, it will not be pointing to the next derived objects. Okay, it will be pointing the next base objects. Okay, so be careful about this. Now, this we have already done. So let's see what is virtual function. So let's see, this is the problem, because see here, we have a derived class, this one. Okay, we have a base class. Okay, although base class pointer have the address of derived class, but if we are invoking the show function, which is both either derived as well as base class, it is not going to invoke the function which is in the derived class. Now, how you can invoke the function in the derived class? It could be done by using the concept of virtual function. So let's see what is virtual function. So virtual function is a member function which is declared within a base class, and it is redefined, and that is called overriding by a derived class. It implements the one interface multiple method philosophy that underline polymorphism. Okay, so the keyword virtual is used to designate a member function as a virtual. So it support, virtual function support runtime polymorphism with the help of base class pointer. So how this could be done? See. So while redefining a virtual function in a derived class, the function signature must match the original function present in the base class. So we call it overriding. It is not the overloading. So overriding is basically runtime polymorphism, and overloading is compile time polymorphism. Overloading is done at compile time, static binding or early binding. Okay, so compiler matches the argument, and depending on the match, the particular function is going to select or invoked. So when a virtual function is redefined by a derived class, the keyword virtual is not needed, but can be specified if the programmer wants. Right? So the virtuality of the member function continue along the inheritance chain. A class that contains a pure virtual, A class that contains a virtual function is referred to as polymorphic class. So let's see how, what is the effect when we write the keyword virtual. We make a member function as a virtual function, and we do not make member function as a virtual function. So this one is the simple, simple base class pointer pointing to the derived class object without writing the virtual keyword. Nahin, without writing the virtual, we have already seen. Okay, if we do not write the virtual in the function, then although the base class pointer pointing to the derived object, but it invokes the function which is in the base class, not the function which is in the derived class. So once you write that function as a virtual in a base class, so this become virtual. To the runtime. Okay, and only the code which is in the derived class, which has been redefined, okay, they are going to invoke. Okay, see here. So we have a base class which is base, and there is a function so, and that has been made as a virtual, and there is a single line of code that is printing just string base. Now we have a derived class which is going to inherit base class. Okay, this we are using the same function, so function, and it has just a single line derived. Okay, now this one is object of base class. If we will print b1.so, means automatically it will invoke the base class. So this will print base, right? Similarly, we have a derived class object. If we just simply invoking the so function, it will invoke the member function of the derived class, and that will print derived. Now, this PB is base class pointer. This would have the address of B1, this base class object. So if you print PB arrow so this will print, this will invoke the so function in the base class, and this will print base. Okay, now we are assigning this D1 object the address of derived class object into the base class pointer, and you are going to invoke the so function. Now this time, since we have made this so function in a base class as a virtual, it will not invoke. It will only invoke the function which is in the derived class. So we say that derived class override this one. Okay, so this will print, this will invoke this particular function, and the function has code like a one line code derived, so it will print simply derived. Okay, so this is the implementation details. Okay, so if you want to override a function, so virtual function could be used just by writing virtual keyword before the function in a base class. It will simply bypass, and it will simply execute the function in a derived class. Okay, some more code is added here. Okay, so some more about virtual function. If you want to omit the body of a virtual function in a base class, we can use pure virtual function. Okay, it makes a class an abstract class. We cannot create any object of such classes. It forces derived class to override it. Otherwise, they become abstract. Okay. So even virtual function could have pure virtual function. Okay. So this is all about runtime polymorphism. Okay. So there are two concepts basically. Polymorphism could be static or compile time polymorphism, that is called static binding. Yeah, okay, and that could be achieved by function overloading or operator overloading, while runtime polymorphism could be achieved by using the concept of virtual function and the using base class pointer, because the base class pointer has the capability to to point base class object as well as the derived class object. Vice versa is not true. If you are say creating a derived class pointer and suppose you want to point base class object, that is not possible. Okay, so that is all about this. Okay, thank you.